So now that you know something about what a condition variable is and a little bit about what the guarded suspension pattern is, let's still continue our prelude, our build-up, our overture to the condition object class itself by talking about some common use cases for condition variables. And this is going to be helpful because without understanding the common use cases, it's a little hard to know why you would ever want to use one of these things. So condition variables are powerful and they're essential for certain things, but they're also a little hard to grok, hard to understand, and hard to apply correctly because they're hard to understand, because there's complicated machinery, a finely tuned Swiss watch is taking place under the hood, behind the scenes. And what makes this complicated is the protocol for using condition variables or condition objects involves several moving parts. Once you understand those moving parts, it's pretty easy to understand, but at first it can be daunting. And to make this clear, I'm taking a diagram from the POSA 2 book, and we're kind of walking through it to explain how it works. So thing to remember, a condition variable is always used in conjunction with a lock. And I'll say this without loss of generality. There could be one condition variable that is associated with a lock, or there could be multiple condition variables that are associated with a lock. In fact, in many of the use cases we're going to be talking about here as we get into the Java condition object API are situations where you actually have multiple condition objects associated with the same lock. And a great example of that would be a bounded buffer, a thread-safe bounded buffer, where you need two condition objects, one to check whether the buffer is empty and the other to check whether the buffer is full. So you have not empty and not full. And there's also several cooperating threads. In this case, we have two. We could have more than two. So without loss of generality, we can have multiple conditions. Without loss of generality, we can have multiple client threads. And also, I will talk later, this will probably come towards the end of the course, you can actually have situations where you have multiple locks as well. And we'll talk about that as well, but that's less common. And then the other thing that you almost always use with condition objects, with condition variables, is something called a monitor object. And a monitor object is really the kind of the wrapper, it's kind of the facade that shields client code from the complexities of the protocol used to implement condition variables. So it's a monitor object that mediates access to mutable shared state. And we'll talk more about the monitor object pattern later. You can, if you want to preview, you can take a look here. It also, at the link at the bottom of the slide, it also appears in the Pattern-Oriented Software Architecture Volume 2 book and the Pattern-Oriented Software Architecture Volume 4 book, if you're curious. Those books make great Christmas presents or holiday presents, so make sure you give them to your friends. And then the other thing that's important is there's an idiomatic sequence of steps, and that's what we're going to focus on, because without understanding the idiomatic sequence of steps, it's somewhat mystical what these things do. The other thing that makes this hard, in addition to having a bunch of moving parts, is that there's the inherent non-determinism of concurrency that makes stuff tricky. You don't always know exactly when threads will run and what their priority is and how the scheduler will do things. So that means you have to do some extra stuff in your code. And again, when you understand the idiom, it's easy, but if you don't understand the idiom, you don't understand why you write the code like that, and you'll make mistakes. And the main way that you solve this issue of the non-determinism of concurrency is you use loops, and you typically use a while loop, and you typically say, with the lock held, with the monitor lock held as it's called here, while the condition is not satisfied, condition await. That's the idiom. So there's loops that are typically used here. So let's kind of talk through the scenario here, and I'll use this to kind of illustrate the steps. So let's say we have a monitor object, and let's say that that monitor object is implementing a thread-safe bounded buffer, like array blocking queue or link blocking queue. Actually, array blocking queue is a better example here because link blocking queue uses a slightly different technique in Java. So let's say that there's methods such as put and take. And those methods are so-called synchronized methods, which means that they are going to be using mutual exclusion. And as it turns out here, they're also going to be using the guarded suspension pattern. So here's what happens. Let's say client thread 1 comes along and it calls sync method 1 on a monitor object like array blocking queue. And sync method 1, to be very concrete, is going to be the take method. And the semantics of take are, while the number of elements in the queue is 0, await the non-empty condition being signaled. So what will happen here, assuming take is called is we'll first acquire the monitor lock, which means we lock the reentrant lock that guards the state of array blocking queue. We talked about this when we talked about the reentrant lock use case for array blocking queue. And we then do some work. And the work here is to check to see with the lock held, hey, what are the number of elements? What are the number of messages in this array blocking queue? And if the answer is 0, then we're going to go ahead and call the await method on the not empty condition. So there'll be a not empty condition variable, condition object in this case. And we're going to call the await method on that. And that is going to put the thread to sleep and release the lock. And those things will be done atomically. So they both happen at the same time with no window of time that would allow race conditions or lost wake up bugs to come sneaking in and cause havoc. So at this point, this thread, client thread 1, is blocked on the not empty condition and the lock is released. So then at some other point, another thread comes along. This is client thread 2, and it's going to call another synchronized method. And in this case, just to be concrete, it's going to call the put method. So it's going to put something into the queue. So of course the lock is available because we released it up here when we went to sleep on the not empty condition. The lock is acquired. We do some work. In this case, do work puts an element into the queue because we're putting it there. We're giving one into the queue. And then, this is very important, we notify the same monitor condition that the other thread is waiting on. So we got one thread up here waiting on the not empty condition. We, after doing the put, call the signal method on the not empty condition. And then we release the lock and we go and do whatever we want. And then at some point, the thread scheduler will wake up the thread that was sleeping on the not empty condition, and that's down here. And when that thread is awakened, it has the lock held. So with the lock held, it then comes down and it does work. Now we're back in the take method again. This time, just to make the example terminate, it doesn't always terminate, but let's assume it terminates here. This time, with the lock held, we check, we find that there's at least one element in the underlying list, or the array. And then we go ahead and take that element out, release the lock, of course, and we return the element. So that's the way to interpret what's going on with this code here. Now, condition variables are often not used directly by apps. The app very rarely directly uses the condition variable, but instead it's hidden. The use of condition variables, either one or many, is hidden within other abstractions. And they form the basis for higher level synchronizers in Java. So if you take a look at this stuff, you'll see that there's layers of things, not surprisingly. And a very good example of this would be blocking queues, like array blocking queue, linked blocking queue, or decks. I think there's blocking decks in Java too, that are part of the Java util concurrent packages. So if you take a look at Java util concurrent, it's got a bunch of stuff in it, and there's a bunch of these different higher level synchronizers like array blocking queue, link blocking queue, and their deck equivalents that use condition variables and condition objects under the hood to do their thing, implementing the monitor object pattern. So array blocking queue is a great example of this. And I should mention that, I should note, and we'll talk about this more when we get to it, array blocking queue uses 2 condition objects. Each array blocking queue instance has a pair of condition objects, one for the not empty condition and one for the not full condition. There's also other ways of doing these kinds of things in Java, of course, that reflect its history. And if you recall, when we talked about the history of Java, I talked about how in the early days of Java, we had these more primitive kind of built-in mechanisms called monitor objects, which have the synchronized keyword and the wait, notify, and notify all methods. And those are available in Java today, but I won't say they're deprecated, but I would strongly advise not using them in this way. And we'll talk about why when we get into this in more detail. The monitor object pattern is really the underlying abstraction that is used in practice to encapsulate condition variables and or condition objects and or monitor monitor locks and so on, intrinsic locks or entrant locks, whatever you want. And so again, you can learn about that pattern here at this link, or go take a look at the Pattern-Oriented Software Architecture Volume 2 or Volume 4 books. So that's the end of our discussion of common use cases for condition variables. We will look at a specific use case involving array blocking queue here shortly before the end of the day, but I'm just kind of giving you the heads up view that you don't usually program to condition objects directly, but you abstract them and hide them behind other more higher level abstractions.